Hi, welcome to Expanse tension theory. Today I'm going to build a bridge. It's a bridge between pure theory and pure empirical result. And it's a causal mechanism bridge that connects the two. So let's just back up a minute. Several months ago now, I published a paper on expanse tension theory foundation stone, the underpinning quantum field theory mechanism that makes all of quantum field theory work. The proposal was a real Gauge-Invariant Singlet scalar field which couples to the Higgs-Portal using a continuous density dependent modulation. That simple thing sounds simple. It's fully permitted within quantum field theory. So many individuals now have told me, yes, that's fully permitted within the standard and existing rulebook of quantum field theory. And what it does is say the world works as Einstein describes mathematically how it works in our local area and zone of where we've measured it, say within the heliosphere. But beyond extreme low density and extreme high densities, way beyond human endeavour or test, the physics change because of a environment density dependent physics that changes in the outer regions of galaxies and at the point of late time acceleration and other places. So pure theory. Okay, that paper, by the way, is currently undergoing peer review in monthly notices at the Royal Astronomical Society, which is really exciting. So peer review is the standard. And when they review that paper, as I understand, it is fully permitted within the existing boundaries of quantum field theory. If that paper's published, it's the foundation stone upon which I've built a 1,000-story tower block of evidence, proof, resolutions to things. So exciting if that paper's accepted, but pure theory. Within the last 3 or 4 weeks, I published a purely empirical review. It had nothing to do with expanse tension theory whatsoever. I downloaded a 6 million star random sample, 6 million stars from the European Space Agency's Gaia Space Telescope database, and I went looking for something. I was looking at vertical velocity, how the stars fluctuate in vertical height because it's less conflicted and confounded with other anomalies than rotation speed, but it matches anomalous velocity, dark matter. Okay, so the vertical velocity still relies on the restoring force. You have a star flying high, Z, from the midplane. It needs a restoring force still to bring it back. So it still relies on gravitational attraction, and it comes within the bounds of dark matter. The result was a 99.998 statistical confidence that the onset of change in velocity, dark matter, happens at the expanse tension theory predicted 10 to the log minus 21.6 kilograms per meters cubed. It is baryonic mass density that is the factor that can predict the onset of this anomalous velocity. Not radius, not geometry, not acceleration, not some dark matter halo effect. It's baryonic mass density. I'm quite pleased with that. But that paper in itself was purely empirical. You can go right now to the European Space Agency. You can go to the Gaia archives. You can go and conduct a 6 million star sample. You can analyze that sample. Within the paper, I explain how I did it and the search mechanism, so you can repeat that piece of work. And I believe it's a repeatable, reproducible piece of work. You will find the density threshold predicted by expanse tension theory many, many months ago. Now, what this paper I've done, and it's now Zenodo paper 18304867, is the mechanical bridge, the mechanism bridge, the causal bridge. And what that paper does, and what I'm now doing, is saying, if the theory is correct, if we have baryonic mass density dependent universe, then, and if the empirical result from the Milky Way galaxy is correct, then it must have mechanism cause. there must be something that explains. Okay, so given the density response scalar vector of expanse tension theory, what would be an unavoidable dynamical response for the universe? And the answer is, well, the unavoidable dynamical response of the universe would be what we saw in the empirical paper. That's quite clever. So for the first time in expanse tension theory, theory meets empirical result, independent empirical result, head on, and the mechanical bridge shows if the theory is correct, the unavoidable consequence would be the empirical result. What doesn't the paper do? And I know I have to teach myself to be very, very careful. It doesn't derive the full scalar field theory at all. I've not reanalyzed the Gaia data in any way. I've taken that exactly as provided. I simply overlaid the density model of the universe to use for density, so that's a standard way of doing it. I haven't completed any tuning or fitting of the data in any way, shape or form, so the paper's extremely careful not to include any circular fixes tuning, so again, I've been very, very careful to do that. The paper also says that the Milky Way in itself isn't a special case. It says, again, if the theory is correct and if the empirical result is correct, then all galaxies should show this. Now, in this bridge paper, this mechanism bridge paper between the two, I mentioned very carefully that I also have studied the 175 star galaxies within the Spark database. So a sample of 175 galaxies, other galaxies, and I've also found with a chi-squared statistical result of 0.985 that the onset of anomalous rotations in the Spark galaxy database is also 10 to the minus 21.6 kilograms per meter cubed. The general expanse tension theory onset density threshold for anomalous rotation. It's a rotation. The paper is falsifiable. I list in detail how this result could be falsified. Again, it's empirical, publicly available data, and I go through and say, well, if future observations fail to find the density anchored transition, the paper's falsified. If vertical dynamics organised by any other clean variable factor, then it's falsified. My paper shows it isn't radius, it isn't acceleration, it isn't the galactic halo dark matter. Now, the fact it's not acceleration is kind of awkward for MOND. You see, modified Newtonian dynamics says the factor for the onset of anomalous rotation is acceleration, which this paper says it isn't, it's density. So the paper carefully states that if baryonic mass density is the factor, then MOND has a problem to overcome. It has an additional constraint, an additional factor to work into its mathematics. So to close the video, what I'm doing with expanse tension theory is looking for a factor to add to, well, actually the theory's deeper, it's a deeper underpinning causal quantum field theory, but I'm still looking for a factor which previously hasn't been considered. Now, through time, Sir Isaac Newton discovered that distance mattered in what he called gravitational attraction, the inverse square law of gravitational attraction. Einstein discovered that the invariant nature of the speed of light mattered, and all of relativity was founded off a factor which he discovered for the universe. Planck discovered that quantum of action, this smallest possible unit, mattered. And again, we have the Planck constant, Planck length, Planck mass, etc., etc. Smallest possible quantum values matter. Now, my work suggests very simply that density matters. By the way, there's no current theory in the world today that says density is the causal mechanism factor. So what the paper does, if the theory is correct and if the observation is correct, then the physical mechanism must exist. And the physical mechanism, without tuning, without any additional fitting of data, fits. Okay, please take a look, share. Thank you for subscribing. Share with others who might be interested. Bye-bye.